So students, in your first part and second part of disaster safe design and constructions, we have discussed about how we can design and construct a particular safe construction for earthquake, cyclone and flood. So now today we will discuss about a particular disaster that is called tsunami. Okay. So basically this tsunami is a series of waves in water body. Okay. So this 2004 Indian Ocean tsunami that was very devastating. Okay, and generally it is caused by the displacement of large volume of water, and generally it occurs in ocean or sea. So basically the reason behind this tsunami may be earthquake, volcanic eruption, submarine landslide, some coastal or rockfall, or some underwater explosions above or below water. So these are all the potential or causes behind particularly tsunami. So that will give rise to your particular sea waves, and this particular sea waves, it may rise in the range from 3 meter to 30 meter, and sometimes it is observed that it has risen up to 50 meter also. So in certain uh, exceptional cases, very high height of this particular sea level that is also observed. So it is very essential that all the people who are living nearby such coastal region, and which is generally prone to tsunami, the tsunami proof construction or some design aspect that are to be followed. Okay, so we will discuss about that. So as far as this tsunami construction is considered, BIS, that is Bureau of Indian Standard, they have given criteria for tsunami resistant design of structure for the safety of natural habitats against tsunami and storm surge. So here general safety measures which are to be provided as per our BIS standard that are given. So that we will discuss one by one. Okay. So as far as this design considerations are concerned, general safety measures to be provided are: first is submerged sand barriers in the water depth up to about 6 to 8 meter. So sand barrier you can provide. Okay, so that submerged sand barrier can be provided up to depth of 6 to 8 meter. Then you can also provide sand dunes, જે sand dunes જે છે, along with the seaweeds or shrubs, nana tree that can be provided. So basically they will provide the safety against the very high tide that is generated during the time of tsunami. Also you can raise the ground level above the design water level with the natural beach sand. जो भी आपकी sand होती है beach sand, उससे ही you can raise your normal ground level, so that it will save the coastal region from the whatever that sea level rise occurred due to tsunami. Then you can also develop the coastal forest, so you can have the green belt. So generally you see that near particularly beaches, generally the coconut trees that are generally planted. So this green belt, by planting the coconut trees along the coastline to cover the minimum of about 500-meter width of the beach, so that will also protect the area from this high level of rise during tsunami. So they can protect that particular coastal region वहाँ पे अगर कोई house है तो. So that is the reason why generally you can see many such kind of coconut trees near your beaches. Also the periodical dredging. Dredging means to clear off whatever obstructions are there in the inlets and associated water bodies. जो भी associated water bodies है, so उसको आप clean कर दो. So at the time of tsunami, they can absorb certain amount of water. So that can also be done. Also the construction of submerged dikes, 1 or 2 rows along with the coastal line, and that will also decrease the impact due to incoming tsunami. So certain placing of certain stones, etc., that will be used for the construction of dikes. So that can also save very high tide which is generated during tsunami. Also this kind of wall, which is generally called as the sea wall, that can be also constructed. So that will save the surroundings around your particular coastal region from the very high tide which is generated during such tsunami. Also this establishment of mangrove plantation. So these are very general things that are generally done nearby coastal region by the plantation of mangrove. So that will act as a coastal defense against tsunami waves. And for the communities who are residing near that coastal regions. Okay, so these are some of the measures in general that can be applied for the area nearby people are living, then in the different manner, like construction of sea wall, some sand barriers, sand dunes, mangrove tree plantation, or the particularly that coconut tree plantation, all will serve as a barrier against the very high tides or the high rise in sea level, and that will not affect that particular people. Okay, so this kind of constructions that you might have seen nearby coastal region, these are all the barriers that will protect the particular communities living nearby this area. So basically, specific design principles that are to be followed for the area near tsunami prone region. So to know the tsunami risk at the site, we have to decide this distance from sea. So where you are constructing, okay, so that is very important. कि sea से कितना distance है. Then elevation above mean sea level. जो भी आपका एवरेज सी लेवल है उससे कितना हाइट पे आप कंस्ट्रक्शन कर रहे हैं. हाइट ऑफ हाई टाइड अबाउ मीन सी लेवल. So what is the probable high tide that can be generated? That should be known to you. So accordingly, you can design your house. Okay. Maximum run up of tsunami. So basically, this is the normal sea level. Okay. And generally, whenever tsunami takes place, there would be rise in a sea level. So here, this is the coastal area. So here, this is the distance up to which it is traveling. So this is called as the run-up distance. And this is the run-up elevation. So this much is the height that is increased. So you should know up to what elevation or up to what height it will increase and up to what distance it can travel. So accordingly, you can give the criteria. So that maximum run-up of the tsunami above the site elevation, that is to be known to us. Then depth and speed of the tsunami waves for the design purpose, because this depth and particularly speed at which it will reach, that are the particular points that are to be known to particular contractors or those who are going to construct certain housing, or that may be for the some hotel or for some apartment. So avoid new construction development in the tsunami run up area. जहाँ तक आपको पता है कि यहाँ तक तो सुनामी का पानी आ ही सकता है, so you should not allow any construction or development in that particular tsunami run up area. And or you can take the adequate precautions to protect such kind of structure, because it is generally observed that nearby beaches normally hotels वगैरह होते हैं, ठीक है ना, because these are used as a tourist spots. So generally that construction should not be done in that tsunami run up area, and though if it is constructed by certain special permission, then some precautions are to be observed. So there is a role of land use planning, कि कैसे land को use करना है. So there is a local context in that. So as per that authority, whatever laws are there that they have to follow, they have to understand the trade-off. Means कितना फायदा कितना नुकसान, and then after they have to give the permission. Review and update existing safety elements. Whatever safety elements that they are having, that should be reviewed and updated. Also these land use elements that should be updated. All these zoning, other regulations and land use planning strategies, all are to be properly reviewed and updated, and then only the permission should be given. So as far as the site planning strategies are concerned to reduce the risk of tsunami, so first thing is that avoiding the impact of tsunami by building on high ground. Okay, so generally it is observed that whatever coastal region is there, nearby building, they are constructed on high ground. So whenever certain tsunami, the high rise in the sea level, that the building can protect themselves because it is constructed at higher elevation. Okay, then slowing the tsunami waves by frictional technique. So that is generally observed, already we have discussed, by forest, some ditches, some slopes and bombs, seawall construction, though that can be done. Deflecting the tsunami away by using the angled wall construction. So some angled wall can be constructed. So it's like sea wall, okay, and that is suitable for the important installations or fishermen habitat, because fishermen, they might be living nearby that area. So to protect them, such kind of angled wall construction can be done. Then stiffened, strong structural design is to be adopted. So that may result in costly building. So proper structural design has to be done. High-rise building with open ground story. नीचे ground पे कुछ नहीं करना है आपको. That should be kept open. So if there are certain waves are there, so they can save people. And these may be hotel, offices, anything. Stilted building. Basically, what is stilt? Stilts are post or pillars. So generally, if high ground is not available, then in that case, artificially you can raise your building, and that is you are providing your building on either poles, pillars, or post. Okay, and they will allow a structure or building to stand at a distance above the ground level. So these are some of the measures that can be adopted while doing site planning strategies to reduce tsunami risk. So here you can see this kind of angled wall construction. So that can reduce this force of particular tsunami waves, and also it will protect this much height, and whatever coastal region nearby some people are residing, then they can be saved. Also this kind of stilted building, so this building completely resting on some pillars, so this kind of construction is normally observed nearby coastal region. Next is tsunami resistant building, some new developments. So basically, it is locally applicable to the tsunami hazard information on design intensity. So tsunami hazard information should be known to us. Performance objective, जो भी हम building construct कर रहे हैं, उसका performance objective we should know. It is mandatory to use the building codes for the design criteria. So whatever codes accordingly they have to design. It should also ensure against multiple hazard environment. So if certain area is such that multiple hazard has, so all the hazard that are to be taken, and they should be integrated in design. So to make your particular construction that is multiple hazard proof, all the construction should be done by qualified engineers and architects. They should have knowledge of earthquake, wind, tsunami resistant planning and design. Then only they can design a proper construction. And also you have to ensure the quality construction, all the materials, all the methods, whatever that you are choosing, it should be of good quality. Then all common buildings cannot be designed for the tsunami water, because it may become very costly. So you have to go for the which kind of buildings you need to go in particular specific design, okay, against tsunami water. So development of design criteria. This is the basis of design criteria. So considering the multiple hazard proneness of the coastal district, the design criteria have to cover the following aspect. So if we consider that a coastal region that may be affected by tsunami, that may be also affected by cyclone, some earthquake may be there under the sea. So all the multiple hazards that are possible. So looking to that multiple hazard proneness of the coastal district, the following design aspects are to be considered. So you have to find out the design wind velocity under cyclone condition. अगर cyclone आता है तो कितनी wind velocity हो सकती है, effective wind pressure near your sea coast, height of storm surge, कितना height हो सकता है with concurrent tide level, then tsunami effects, that is height and velocity of tsunami waves, hydrostatic water pressure, कितना pressure बढ़ सकता है, then debris impact, some debris are also coming, then wave break impact due to waves, some breakage may take place, then earthquake effect, so design seismic coefficient. So basically you have to consider your design as far as multiple hazard proneness of the coastal district is there, and accordingly you have to consider all cyclone factors, then tsunami factors, earthquake factor, as well as fire safety that is to be observed. Then flood inundation means kitna flood आएगा due to tsunami. So what will be the flood velocity, what will be the depth of flood inundation means कितना पानी में जाएगा आपका area. So these are all the criteria that are to be followed for any development near tsunami prone region. So basically all the building aspect that are common as we have seen in earthquake resistant structure: size, shape and height of the building, use and importance of building, then either it is on stilt means pillars पे post पे है, या without stilt you are designing, Then the roof that will act as a shelter. So whenever there is certain tsunami kind of thing is there, so flooded, it is flooded everywhere. So generally people take particular roof for the shelter purpose. So generally it should be flat. Okay, so in that case you should consider live load also कि कितने लोग वहाँ पे रह सकते हैं. So that live load also you have to consider. Then choice of building material and construction technology. This is particularly related to quality aspect, durability of the building, that is related to life, कितना life तक चल सकता है, what will be the life of a particular structure. Then thermal comfort, temperature wise. So these are all the normal building aspects that are to be followed in construction of tsunami risk area also. Now here, according to the importance of building, the particularly tsunami proof building can be constructed. Okay, so here these are the use of the importance of building. So first is ordinary building. So different level of safety that can be provided. So housing and storage that are generally considered to be ordinary structure. Next is important structure, in which hospital, school, fire station, powerhouses, substation, telephone exchange, VIP residence, etc. And very important installation, that is cyclone and tsunami shelter. So at least they should not be damaged, because ultimately people are to be evacuated nearby that region and that are going to get shelter in whatever shelters which are created. So these are considered to be a very important installations. So performance level desired, there are three level of performance which are generally desired. First is minimum performance. तो कोई भी बिल्डिंग है अगर उसका मिनिमम परफॉर्मेंस हम देखें, सो इट शुड नॉट कॉलेप्स. सो नॉन कॉलेप्स, दो सम स्ट्रक्चरल डैमेज में भी देयर, कुछ स्ट्रक्चरल डैमेज हो जाएगा बट इट विल नॉट कॉलेप्स. ओके, सो दैट इज द मिनिमम परफॉर्मेंस लेवल डिजायर्ड. सेकेंड, इफ यू आर सेइंग इट्स सेफ, सो इट इज डैमेज्ड बट विदाउट सिग्निफिकेंट स्ट्रक्चरल डैमेज. थोड़ा डैमेज होगा बट स्ट्रक्चरल डैमेज बिल्कुल नहीं होगा. ओके, then next is operational. So it is best one that is capable of avoiding, resisting all the expected hazard and forces. So depending upon the importance of building, you can have the different performance level desired, and accordingly you can design. Okay, so now whenever there is a phenomena of inundation, means पानी से भर जाता है area. So what are the effects and what are the design solutions that can be suggested in tsunami prone region? So if there are chances of flooded basement, कि अगर basement में ही flood आता है पानी, so choose the site at higher elevation. This is the obvious solution. Okay, only water is coming, so that will flood only basement, means below ground level. So you have to provide your particular building at higher elevation. Next is flooding of lower floors. अगर lower floor पे भी पानी आ रहा है, so raise the building above flood elevations or stilted type of construction. So that should be above your pillar or post. Okay, so still you have to raise your building. So these are all things that can be known only if you are having previous studies. Okay, so and accordingly you can get all this idea, and accordingly you can give your design solutions. Flooding of mechanical, electrical, communication system and equipment, if these are the chances, then do not stake or install vital material or equipment on floors or basement lying below the tsunami inundation level. So at least if you are knowing that up to this level the tsunami water may come up, तो उस level पे आपको ये सब चीजें रखनी ही नहीं है. Okay, it should be kept at higher elevation. Then damage of building material and component, if it is going to take place, then protect hazardous material storage facility that you have to protect if it is located in a tsunami prone region. There are also chances that contamination of affected area with the waterborne pollutant, along with that tsunami water, some water pollutants are also coming. So that will also damage your mechanical system and equipment. So they should be provided at higher elevation. Also they will try to rust or that is corrosion may be possible. So that corrosion resistant concrete and steel are to be provided in certain type of building, just to protect all this from such pollutants or contaminants. If hydrostatic forces are coming, पानी का water आ रहा है, पानी का force आ रहा है, so elevate the building above flood level, that is the but obvious solution. Then provide adequate openings to allow the water to reach equal height inside and outside the building. बाहर और थोड़ा सा opening provide कर दो, so that can be maintained. Design of static water pressure on wall. So whatever pressure that is going, accordingly you have to design your wall. आपको पता है कि इतना तो lateral pressure आने वाला है, accordingly you have to design. Then consider suction tension on walls under receding water. Whenever some water that is receding, so there are certain suction tension are developed on walls. So accordingly you have to design your walls. Then buoyancy flotation, buoyant force लगता है, it may float your building. Okay, so elevate the building above flood level, that is the obvious option. Then anchor, you have to anchor your building properly to foundation so that it will prevent this flotation, वो ऊपर तैरने नहीं लग जाए, ठीक है ना. In Japan tsunami you might have seen the footages in which पूरा का पूरा घर पानी के साथ बह रहा है. So that buoyancy flotation for that proper anchorage of the building with the foundation, it is very essential. Also some saturation of soil causing अगर saturation पानी से बहुत भर गया है तो पूरा आपका slope instable हो जाएगा, loss of bearing capacity हो जाएगा. So these are the obvious thing that may happen. So you have to evaluate your bearing capacity and shear strength of the soil. आपको strength check कराना पड़ेगा, and accordingly you have to support your building foundation and slopes. And as far as possible जो भी आपका slopes और setbacks है, it may be destabilized when it is uninundated. Means जब भी पानी भर जाएगा, so you have to avoid the slopes or setbacks from the slope. जो open space आप provide करते हैं, that you should avoid on the destabilized slope. Okay. Next is hydrodynamic force. So basically this will push, it is the pushing force on the front face of the building, and some drag can be caused by the flow around the building. चारों तरफ पानी भरा हुआ है, so it will push as well as it will cause a dragging force. So in that case you have to provide at higher elevation to avoid the flooding, and also design for the dynamic water force on wall and building elements. Also you have to anchor the building. So these are all the provisions which are very common and that can give solution against many effect. If debris impact are there, debris आ गया साथ में, so again you have to go with the elevation, higher elevation to avoid the flooding, and you have to design for the impact load, sudden load, उसके लिए आपको design करना है. Then embankment का instability हो गया, whatever embankment is जो भी आपने रखा है, that particular embankment, if it has become unstable, then saturated soil without water in front, that is the solution. And also provide the adequate drainage system just to pass on the water. Then if some scour is there, then proper design is to be done to protect against scour and erosion of the soil around your foundation and piles. Basically that is pile foundation, that if it is used, then it is to be designed in such a way that it is scour resistant. So these are all the possible solutions that can be applied when there is a phenomena of current, waves and waves break and bore. So inundation, if some current and waves are coming up, in that case all these design solutions can be applied. Now these are the common RCC design criteria that can be applicable for all coastal areas, and this concrete which is exposed to coastal environment, which is taken as severe. So generally plain if plain concrete, if you are using, minimum grade is M20, minimum cement 250 kg per meter cube, maximum water cement ratio 0.5 is to be used. If RCC, reinforced cement concrete, if you are using, minimum grade of concrete should be M30, means after 30 days it will give you 30 Newton per mm square compressive strength. Cement should be minimum 320 kg per meter cube, maximum water cement ratio 0.45, and aggregate maximum size 20 mm. Also reinforcement bar, जो સ્ટીલના જે સળિયા આપણે યુઝ કરીએ છીએ, that should be TMT HCR, that is high corrosion resistant steel bars, that is FE 415 up to 2 story and FE 500 for frames in taller building. So these are some of the specifications which are common. Then minimum cover to this HCR enforcement, अगर स्लैब कंस्ट्रक्ट कर रहे हैं तो मिनिमम कवर शुड बी 20 mm, बीम के लिए 30, and for column it should be 40. If you are using hollow concrete block, it should be casted using M20 grade of concrete with use of fly ash. So generally this TMT reinforcement HCR FE 415 bars that can be used in conjunction with M20 concrete grade. So these are the RCC design criteria for all coastal areas. Now next we will discuss about industries, because nowadays all our residential area, they are merging with industries. So basically these industrial hazards are threat to people as well as our life support system, and that arises from the mass production of goods and services. So most of the goods and services that we are getting from production from industries only, so they are essential. But if some industrial accidents are there, so that is generally considered to be a man-made disaster. So that disaster can be avoided, because such disasters, because they are man-made, and if we try and if we provide certain safety arrangements, and if we keep some watch and some strict actions are to be taken against industries, then such kind of industrial accidents can be avoided, because it result in great damage, injury and loss of life. And as far as our Gujarat is concerned, it is highly prone to natural disaster, and which can also trigger the chemical disaster, because so many industries are there. So that can also trigger our chemical disasters also. So we should know about this industrial construction also. So if this is regarding the planning of industries, okay. So if certain ecologically sensitive area or certain sensitive areas are there, so sensitive area किसको बोलेंगे? Wildlife habitat area, steep slope है, wetlands है, and prime agricultural lands. So these are generally considered to be ecological sensitive area. So it should be kept at least 25 किलोमीटर अवे फ्रॉम इंडस्ट्री. अगर कोई भी इकोलॉजिकली सेंसिटिव एरिया है, तो उससे 25 किलोमीटर दूर आपका इंडस्ट्री एस्टेब्लिशमेंट करना होगा. दैट इज द फर्स्ट थिंग. इफ इट इज नियर बाय कोस्टल रीजन, कोस्टल एरिया है, so it should be 0.5 kilometer away from the high tide zone. Similarly, it is applied to flood plain. It should be 0.5 kilometer away from the flood plain. Transport and communication system, so at least 0.5 kilometer from highway and railway. Minimum 0.5 kilometer away from highways and railways. And industries should be placed at least 25 kilometer from the projected growth boundary of settlement. Means जहाँ पे कोई गांव है या, so that you can see that all these GIDCs etc., they are now merging with the residential area. Okay, so but at least when they are constructed, the provision was such that it should be at least 25 kilometer away from the projected growth boundary of the settlement. मीन्स आपने एक बाउंड्री डिसाइड कर दी कि यहाँ तक आपका पर्टिकुलर रेजिडेंशियल एरिया इट कैन एक्सटेंड, तो उससे आपको 25 किलोमीटर अवे यू कैन अप्लाई फॉर योर industries. Okay, but if this settlement is going on increasing and increasing, then this will become nearby your industries. Okay, and that is generally that is the problem that we are facing nowadays. All these GIDCs etc., that are just merging with the boundaries of the residential area. Okay, so here site selection is very important. Environmental factors that are to be considered and balanced with the economic growth. So it should not harm environment. Okay, that air pollution, land pollution, then noise pollution, water pollution, because all are possible whenever some industry is coming up. So all the environmental factors are to be considered. No forest land should be converted to non-forest land. So normally it is happening that कि forest land को non-forest land में convert करके industry का permission मिल जाता है. No prime agricultural land should be converted into non-agricultural land. So this should be the provision. Then within the acquired site, industry must locate itself at the lowest location. So it should remain obscured from the general site. मतलब general site से उसका construction थोड़ा नीचा होना चाहिए ताकि वो दिखे नहीं. Okay, then space should be available for industrial wastewater treatment. जो भी waste water वहाँ से निकल रहा है, just to avoid the water pollution, that industrial wastewater treatment should be done by the industry. So generally in all the industries, they are having their own wastewater treatment plant. If they are not having their own wastewater treatment plant, then at least all the industries they can have some common एफ्लुएंट ट्रीटमेंट प्लांट, जो भी एफ्लुएंट निकल रहा है इंडस्ट्रीज से, सो उन सबको कंबाइन करके एक CTP जिसको बोलते हैं कॉमन एफ्लुएंट ट्रीटमेंट प्लांट, दैट कैन बी अप्लाइड. रीयूज एंड रिसाइकलिंग ऑफ द ट्रीटेड वाटर टू बी डन टू रेज अ ग्रीन बेल्ट, एक्वाकल्चर, रिक्रिएशन एंड एस्थेटिक वाटर बॉडी. Okay, and green belt should be at least 0.5 kilometer wide around the limit of industry. Industry के बाहर minimum 0.5 kilometer तक green belt होना चाहिए, and 1 kilometer wide if there is a order problem. So that can be extended to 1 kilometer if some orders are coming from the industry. So it is the basic requirement of the industries. Then green belt between two adjoining big industries should be 1 kilometer. If two big industries are there which are nearby, then minimum 1 kilometer green belt should be provided between these two industries. So these are all the provisions which are there, but if they are followed, then only its implementation, if it is done properly, then only we can see the result. Enough space to store the solid waste and probable reuse and disposal. Whatever solid waste that they are generating, for that they should have certain storage space. Also they should have all the probable reuse aspect, कहाँ reuse कर सकते हैं, और disposal करना है तो कहाँ पे disposal करना है, safely dispose करना है, so that to avoid the land pollution. Okay, so this solid waste management is also to be done by industry, so that it should not result in some disaster. Then minimum 3 ambient air monitoring systems should be installed. This ambient air monitoring system that will continuously monitor the air quality. Okay, just to avoid air pollution, minimum 3 surrounding air में कितना pollutant है, that are to be checked. So all the provisions for water pollution, land pollution, then air pollution, all are to be taken care by the industry as per our particular laws. Then associated township must be created a space having physiographic barrier between industry and township. So generally township और इंडस्ट्री के बीच थोड़ा बैरियर होना चाहिए. ओके, एंड दैट आर टू बी प्रोवाइडेड. देन सीनिक फीचर्स ऑफ द प्लेस शुड नॉट बी अफेक्टेड. कोई अच्छा फीचर्स है तो उसको आपको डिमोलिश नहीं करना है, इट शुड नॉट बी अफेक्टेड. एंड ऑल द प्रोविजंस विच आर available in our Environmental Protection Act, which is EPA 1986, that are to be followed. So Environmental Protection Act, it is the umbrella act that will be useful in saving our particular surroundings, nearby industrial area, from air pollution, water pollution, noise pollution, then land pollution. So all are provisions that are to be followed by the local pollution control board. In Gujarat we are having GPCB, that is Gujarat Pollution Control Board, and at central level we are having Central Pollution Control Board. So that are to be properly followed. So if there is certain fire hazards, if they are there, so which kind of things that are to be done, that we will discuss. Okay, so there are certain safety measures for the design of factory premises. So factory jo hai, it should have adequate layout, and whenever certain accidents take place, then they should have emergency exits. So emergency exit, it's compulsory. Then first aid arrangement, if some industries they are having some accidents that is taking place, then first aid arrangement, it should be there. And also there are certain safety measures that are to be observed for the machine. Basically it is in the form of interlock guard. Basically here in this figure you can see there's some guard is there. Okay, so what is the meaning of this interlock guard? So this machine, it will not start operating if this guard is not placed. Okay, so if it is removed, then automatically this machine will shut down, it will stop. Okay, and certain kind of emergency stop cables that are also there, that can be manually operated. Some electrical interlock switches that are also there, so that will stop functioning. Okay, and that will safeguard. So such kind of interlock guards that are generally provided in industries. Then enclose the dangerous part with suitable casing. If you are knowing that some part of the machines that are very dangerous, then you should try to enclose them. Then dangerous part should be out of reach during operation. So no one should reach to that particular dangerous part, because it may result in some industrial accidents. So you should provide certain safety measures against fire. So proper firefighting system that should be available. Okay, then proper storage of explosives, because some explosion may take place. So proper storage of all the hazardous material, toxic material, all the explosives, they should be properly stored, as well as they should be properly handled, as well as they should be properly disposed. And adequate emergency exit at the time of particularly fire hazard, that are to be mentioned. Also some safety measures against the electric hazard that are designed. So warning signals are always there. Okay, then it should have underground cable, all the safety fuse, etc. So all the possible measures against fire, for protecting the machine, safety measures for machines as far as the design is concerned, all are to be followed. Okay, so here for preparing this presentation, I have taken a reference from this NIDM guideline for designing safe house in earthquake-prone region, particularly all the guidelines that are given by NIDM, as well as this AIEE, that is a manual, that is in which there is a general concept of earthquake-resistant design was given. Also, all the guidelines related to this particular tsunami and other disaster that are given in the guideline of NDMA that I have followed. So with this, I want to say that construct safe and be safe, and thank you very much. I hope that whatever safe designs and construction that we have discussed for the safety of against different disaster that are properly implemented, because all the laws and provisions that are available in our building bylaws and under different acts. So the only thing is that proper implementation is required. So if they are implemented properly, then all the construction that would be safer for all the people. So thank you very much, all of you.